All right, ready? Number one. Now, you get, I'll let you use your flowcharts because you've got a list of perfect squares on there, right? So I'll let you use that. Even if you don't have your flowchart, the only thing you really need it for is the perfect squares, right? But you have your handy-dandy calculators, right? You can always use that. Go ahead and put the square root of 16 in there if you don't remember, or if you don't have your chart. Hit enter. If you get a whole number, it's a perfect square. So the square root of 16, 4. Try 180. Square root of 180. No, get a decimal. So 180 is not a perfect square, right? Oh, I need to zoom in, don't I? Let's zoom in a little bit. There we go. Okay, so we're going to have to simplify. You guys remember how one way I showed you to simplify? Yep, 180 divided by 2. That gives me a starting point of where to use, start dividing out the perfect squares, right? The next lowest perfect square from 90 is 81, right? So take 180, divide it by 81. Oh, it's decimal. That doesn't work. So the next one's going to be 64, right? 180 divided by 64. Decimal, that doesn't work. 49. 180 divided by 49. Nope, doesn't work. 36. 180 divided by 36. And I get a 5. So that's great. So I'm going to change this to the square root of 36 times the square root of 5. And we know the square root of 36 is 6 square root of 5. Okay. Let's leave it off for now.
We're not really adding or subtracting anything at the moment. We're just simplifying.
Yeah. Yeah, if we were to actually be evaluating or solving or something, then we would need the plus or minus. Okay. Technically, I suppose we should, but we don't. All right, number 5, we have to solve by taking the square roots. This was the second method I showed you, right? We have to make sure that you get the variable squared by itself. This one is. So we go ahead and take the square root of both sides. See how we're solving this one? That's why we're going to use a plus or minus. Okay, that cancels out the power 2, so I get m plus or minus the square root of 90. Does the square root of 90 simplify? I'm thinking of 9 times 10. And 9 is a perfect square, right? So plus or minus 9 times square root of 10. So m equals plus or minus 3 square root of 10, and I know 10 does not simplify. Square root of 10. So there's my answer. Okay, number 7. I have to get the term by itself, the squared term by itself, so I'm going to add 9 to both sides. So I get 2x squared equals 182. Divide by the coefficient 2. And I get x squared equal 91. And take the square root of both sides. X equals plus or minus square root of 91. And we really should check to see if that simplifies. Half of 91 is 45 and a half, so 36 is not going to work. 16. Nope. 9. Nope. 4. Nope. So we're good. That was pretty easy. Oh, one more. I have a 4 being multiplied, so I need to divide by 4. So I have the quantity v plus 10 squared equal 10. Take the square root of both sides. So I get v plus 10 equals plus or minus square root of 10. Subtract 10 from both sides. Be careful, guys. They're trying to trick you here, aren't they? These are not like terms. That one has a square root. So I have negative 10 plus or minus square root of 10. Okay, questions, comments, concerns? All right. Bob Seeger would say, turn the page. Okay, completing the square. Got some steps to do here, right? We have to get in the form of ax squared plus bx equals c. So I need to subtract 77 first. So I get k squared plus 18k. Then I'm going to have to find a perfect square to add to it. So I'm going to put in a number to be added. Negative 77, and then I have to add that same number over here. And the formula for that perfect square, b divided by 2 squared. Yes, it's going to be 9.
So 18 divided by 2 squared.
Yep. We got 9 squared, which is 81. Okay, so I have a perfect squared binomial as a factor, right? So k, my base is a plus 9. Be careful, don't use this one, use this one. Negative 77 plus 81. Oh, isn't that nice? 4. A perfect square. Square root both sides. I get k plus 9 equals plus or minus square root of 4 is 2. Subtract the 9. Good, Ian. Now these are like terms over here, right? K is going to equal negative 9 plus 2, and then negative 9 minus 2. So K is going to equal negative 7. And then negative 11. So hopefully this is getting a little easier for you guys. We generally do plan to spend 3 days or so completing the square because it is a difficult concept. All right, number 15. Subtract 62 for both sides. So I have b squared minus 20b. I'm going to add to it a perfect square. Negative 62. Going to have to add to it that same perfect square. Going to take my b, which is negative 20, divided by 2, square it. So I get negative 10 squared, which is 100. Add it to both sides. So my perfect squared binomial factor is b. Here's my base minus 10 squared. Careful, don't use that one, use this one. Negative 62 plus 100, so positive 38. Square root both sides. Negative 62 plus 100, right? Yep. So b minus 10 plus or minus square root of 38. Going to be reduced, simplified? I don't think so. Nope, I think we're good. Add 10 to both sides. So b is going to equal 10 plus or minus square root of 38. And then the last method. If all else fails, use the quadratic formula, right? I think I even put it on the quiz for you. Negative b plus or minus the square root of b squared minus 4ac all divided by 2a. Okay, make sure you have a 0 on one side of the equation, which we do. So this one, my a is 1. B is negative 3. My C is negative 70. Make sure we don't have a common factor here, a common term, which we don't. So let's go ahead and stick it in our formula. C, negative B, so negative, my B is negative 3, plus or minus the square root of b squared minus 4, my a is 1, my c is negative 70, all over 2 times a, which is 1. Then we do what's underneath the radical in the calculator, right? So I'm going to take my negative 3 squared minus 4 times a, which is 1, times c, which is negative 70, and enter. And I get 289. I think 289 is a perfect square, isn't it?
Yes,
17. Oh, so I'm going to replace this entire radical with 17. So I have x. Negative negative 3 is positive 3. Plus or minus 17. All divided by 2. Okay, so one number is going to be 3 plus 17 divided by 2, which is 20 divided by 2, which is 10. My other number, 3 minus 17 divided by 2. So I have negative 14 divided by 2, so negative 7. And if you want it to look pretty, you put x equals negative 7. I'm a 10. That was pretty easy. And the last one, I have a 0 already. So my A is 12. B is 5. C is negative 1. Let's go ahead and plug it in. X equals negative B, which is 5, plus or minus square root of B squared minus 4AC all divided by 2A is 12. You guys probably at this point are saying, man, I'm sorry that we're so close to being done because this is so exciting. All right, underneath the radical, so you have 5 squared minus 4 times 12 times negative 1, 73. And if you guys ever watch Big Bang Theory, that's the number Sheldon wears on the front of his shirt, right? That's because it's a prime number. So I have x equals negative 5 plus or minus the square root of 73 all divided by 24. And that's it, because you can't simplify the square root of 73. Wasn't that fun? Should we do some more? Should I make up another worksheet for you guys?
No, God, no, please no. Please,
Wow.
please.
You guys just broke my heart.
It was a nice offer.
Thank you, Mrs. Martin. Thank you.
It's a very nice offer, but I think this is a